All right, now we want to discuss atomic structure. And if atomic structure, when we talk about the arrangement of atoms, that's a particular arrangement in atoms, arrangement of electrons in an atom. And let's look at atom itself. An atom is the smallest particle of an element that can take part in chemical reaction. You understand? The smallest particle of an element that can take part in a reaction. And if you look at the structure of an atom, it is divided into three main atomic particles. That's, we have the proton, we have the neutron, and we have the electron. So the atomic structure is telling us that the atom is composed of three main subdivision, which is what? The nucleus, the nucleus, and the revolving electron. So we have inside the nucleus, we have proton and neutron. Then the electron is revolving around it. So those are the three components, or these are the subatomic particles. Now let us move on from there. Now inside an atom, we have the nucleus. The nucleus is the center of the atom, which contains protons and neutrons, and electrons move around or revolves around the nucleus in its shells. So that is the structure. So that's the structure of an atom is just the arrangement of these particles inside an atom. Then if you now let's look at the charges of an atom. We said that an atom contains protons, neutrons at the center, and electrons revolving around it. Now the proton is the positively charged part of the nucleus, while the electrons are negatively charged. Then neutrons have no charge. In neutrons, you have in a neutral atom, the number of protons is equal to what? Number of electrons. Like if you have an example, when you have a neutral atom, the number of protons equals to the number of electrons, but the charges might be different in some cases. So that is that. So if you look at the charges, like I said, protons are positively charged, electrons are negatively charged, while the neutrons have no charge. And that is that. Now that one is now taking us to the next thing, which is the atomic number. Atomic number is the same as the number of protons in an atom. Atomic number is the same as the number of protons in an atom. For example, hydrogen has atomic number of 1. It means that the proton of hydrogen there is what? 1, and the electron is what? 1. So if I give you a question, I'll say, how many protons are there in hydrogen atom? It is what? 1 proton. How many atomic number? 1. Then if you look at more of JAMB questions, JAMB usually use more of electrons just to like confuse you. The JAMB will ask how many electrons are present in the nucleus of an hydrogen. Either the nucleus or the one revolving around it is just electron is 1. So proton 1, electron 1, and so that's that. So atomic number identifies the element. What's the atomic number? Atomic number of sodium is 11. Atomic number of fluorine is 9, or fluorine is 17, neon is 10. It goes on and on like that. So it identifies the element. Then let's move on to the next one. Then the next thing you need to know about this atomic structure is the mass number. The mass number is the same or equals to the number of protons plus neutrons. The mass number is the same as the number of protons plus neutrons. So when I have my proton, I can easily calculate my neutron if I have the mass number. Or if I have the protons and the neutrons, then I can easily calculate what the mass number. Then if I have the mass number and the proton, I can easily calculate my neutrons. For example, the atomic number of sodium is 11. It means that the proton number is what? Is 11. Then from the mass number, from the neutron number, I can easily calculate my what? Mass number, which is 11 plus 12. You can see here. So with 11 plus 12 here, it's giving us the mass number. So it means that proton has an atomic number of 11, which same as the proton number. And also we have the neutron number as 12, and the proton plus neutrons gives us what? The mass number, I can see. So that is the concept of mass number. On this one alone, there are so many questions that you can get. I can ask you to calculate the number, how many neutrons are there. When you have a mass number, a proton number, you can actually substitute each other. Then I can even ask you, if the proton number of sodium is 11, what is the atomic number of sodium? C11. And if I ask you, if the atomic number of sodium is 11, how many protons does it have? The proton is what? Still 11. So the mass number is equals what? Number of protons plus neutron, and you can always maneuver and get yourself. Now inside the same structure, if you talk about the structure of the atom, we still have a concept of electronic configuration, that's electronic arrangement. Electrons are arranged in shells by maximum number of first shell, 2, second shell, 8, and third shell, 8. Then for this level, you can still say it's 8 because it goes on and on like that. So each shells have their own energy level, and so that is it. Now, for example, if I have hydrogen, you see it has 1, and carbon here, we have the orbital configuration to be what, 2 and 4. The valence electron there is 4. What is valency? That is the number of electrons in the outermost shell. Then oxygen here is 2, 6. Then if you look at 2H1, the valency of sodium there is 1 because it has the what? 1 electron in the outermost shell. So it goes, and so the outermost shell is called the what? It's called the valence shell, and the electrons in the outermost shell are called valence electrons. So that's what I just discussed now. And let us move on. If you have, for example, we have a sodium, that's 281. Then we have how many shells we have? We have KLM. That's KLM 281. That's 1 valence electrons, and it goes. Then the same thing oxygen. That's K. If I want to ask you something on JAM, probably you want to write JAM, want to write GC, and somebody asks you that in what shell, for example, let me frame this question like for sodium now. They said, how many electrons are there? How many electrons are there in the outermost shell of sodium? The outermost shell of sodium here is what? Is 1, and that's KLM. That's the M shell. So what is the name of that shell? The L shell is M. And somebody asks you about this 8. That's KM. KL. That's L shell. Then the 2 is what? The K shell. The same thing oxygen. The outermost, the valence electron of oxygen is what? 6, because that's the valence electrons of 6. 6 electrons are revolving around oxygen there, and which determines the chemical reactivity. Don't forget, the valence electron tells us about what? The chemical reactivity. It happens and it occurs in group 7 element as well. They have 7 valence electrons in the outermost shell, which makes them chemically very reactive. Then what about isotopes? Still under the atomic structure. Isotopes are atoms of the same element with the same atomic number but different mass number. They have the same chemical properties but probably different physical properties. So we have chlorine 35 and chlorine 37. Not only that, we have carbon 12 and we have carbon 14. They are both isotopes, although they have the same atomic number but different mass number. So you can see the atomic number of chlorine here is 17. The two isotopes have the same atomic number of 17, but the mass number is 35 and 37. So those ones are isotopes. Uranium 235, uranium 234 are isotopes. Carbon 12, carbon 14 are isotopes. Chlorine 35 and 37, they are isotopes. So it goes, even hydrogen have isotopes. Hydrogen 1, we have protium, we have tritium, and we have deuterium. All of them have the same proton number, but the mass number is different. So that is that about the atomic structure. There are so many questions on this. I'm going to drop those questions in the first comment of the video. So thank you. See you in our next video.